Welcome to SanfordFlipMath. This is PreCalculus. We are working through the Demana Waits Foley Kennedy book. We are deep in the throes of the trig chapter. Our last video we did a little bit of introduction to the shapes and meaning for the terminology, shapes of the graphs for sine and cosine, meanings for the terminologies. What we're going to do today, in this video, is focus on some more meat and potatoes kind of stuff. Like we're going to actually do some graphing of some examples other than just the parent function for sine and parent function for cosine. So for instance, we might look at this graph. Let's say we want to do the sine of y equals 3 times the sine of 4x. So y equals 3 times the sine of 4x. Now, just a quick little note here. I'm going to kind of just throw this on the bottom. Just a reminder that this y equals sine x has a basic shape that you need to, I mean, right now, you know, you're getting familiar again with it. I know you saw it in Algebra 2, but we're getting back in the throes. Remember, the basic shape of this thing has a period of 360, also known as 2 pi. It starts at 0 because the sine of 0 is 0. The sine of 360 is also 0. The sine of 180 is 0. Remember that sine has to do with y values from the unit circle, so if you're not sure what to do, you can think of the y values, and so like the y value at 0 degrees is 0. The y value at 90 degrees is 1, so at 90 degrees, so that's halfway between 0 and 180, so you got to be up at 1 here. Okay, and similarly at 180, you're at negative 1, 0, and 0, negative 1 for 270. So about there, not that. Okay, and so this is the basic shape. Okay, and notice that this is like 4 separate little sections. There's one section here. There's another section here. And the way I always graph it, like 4 separate pieces, because that just helps me to, you know, if I try and draw the whole thing at once, then it ends up a mess. You know, this is too big on the top, too little on the bottom, whatever. So what I do instead is I always plot those 5 points. Those are the only 5 I generally graph. And then based on that, I just sketch from one point to the next. And I'm doing just a gentle curve, and that's what I'm doing. Okay? All right, so that's what we're going to do with this. Now here's the catch. I have a 3 on the outside. Okay, now you need to remember that on the outside, it's about vertical, it's about the y value, and you do what it says. So this is a vertical stretch of 3. Here on the inside, I have multiplication, so remember inside it's inverse, so that means I'm really going to be dividing by 4, so it is a horizontal shrink of 1/4, or in other words, divide your x's by 4. Okay, so watch this. This is going to seem ultra sneaky, and which is of course why I love it. If I was just going to draw the normal trig function y equals sine, okay, so I'm just going to do y equals sine like normal. Okay, so this is 1, this is 360, and then so it starts at 0, it ends at 0, halfway between it's at 0. Halfway between these 2 zeros is a maximum, halfway between the next 2 is a minimum. Okay, so I sketch, I sketch, I sketch, I sketch, and then I say, oh dang, I was supposed to do a vertical stretch of 3. Well, remember that a vertical stretch is also called a scale change. A vertical shrink or horizontal shrink is also called a scale change. So what I'm going to do is I'm just going to change my scale. So it was supposed to be a stretch of 3, I'm just going to change that 1 to a 3. I was supposed to do a horizontal shrink of 1/4, in other words, divide my values by 4, so I'm going to change that to 90. Now, technically what was supposed to happen was I was supposed to have a shape that did something like that. See, this is what happens when you just do it without all your points in advance. You just make a mess. Okay? It was supposed, now that would have been half, so that wasn't even enough, right? It needed to be smaller. So my thought is it's much easier, okay, if we were going to do this by not changing the scale, our graph would have looked like that. Okay, So actually taller than that, up to 3 and then down to, yeah, well, you get the idea. All right, so enough of that. So my recommendation is adjust your scale. Okay, so we've done one cycle, one period. We went from 0 to 90. I normally like at least 2. Now, if you want to go 2 on the right, that is fabulous. Okay, so here's another cycle. Or some people like to do, they just, have this thing for symmetry, and so they would want to do one on the left as well. So maybe, they instead of having, maybe they wouldn't bother with that one. They'd have those 2 cycles instead. So it doesn't matter to me. Usually what I end up doing is 3 so that I can make both groups happy. Okay? All right, let's do another one of those. Let's answer some questions first. Okay, first of all, what's the domain? How far does this keep going left and right? Well, I can keep wrapping around a unit circle a million times, and I can even go backwards a million times. Okay, so the idea here is that the domain, there are no jumps or breaks, all real numbers. Always true for every sine function, it's always all real numbers. Okay, the range, well, normally the range for sine goes from -1 up to +1, but because this time there was that vertical stretch of 3, it actually goes from -3 to +3. Now again, I know some of you don't like that notation, so if you would rather do this instead, you are welcome to do that. Okay? Amplitude. Amplitude is supposedly max minus min over 2. Okay, well the maximum in this case is 3, minus the minimum is -3 over 2, so this is 6 over 2, 3. Okay, the period is how long it takes the change in x before it starts repeating. Okay, so this goes from 0 to 90 before it starts repeating, so the period is 90 degrees. There are no shifts either way, or if you want it so 0, or if you want to say not applicable, or ha, you can't fool me, Mr. Sanford, I know what it is, none. So that works too. Okay, quick little note here. I know most of you are very content to live in degree land, and I need you to be aware that life happens in radians also. Okay, so if I tell you that you have to do this in radians, what changes? Well, the only thing that changes is the x's. So instead of writing 90, we would just write pi over 2 here. Now, if you were going to write more of the scale, well, half of pi over 2 would be pi over 4. Half of pi over 4 would be pi over 8. So here's pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, also known as pi over 2, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8. Well, 8 pi over 8 is pi. Well, pi over 2 and another pi over 2 is pi. All right, so period in this case could also be listed as pi over 2. Okay, amplitude doesn't change. Amplitude is not affected by what units your angle's in. Okay. All right, now one other thing to point out here, and that is, notice how my amplitude was 3 and that number in the front was 3, and here's a cute little formula for you. I knew you'd be excited. Okay, period in this case was 90 degrees. Well, how did we get that? We did the normal period of 360 divided by 4. Well, here's another cute little formula, 360 divided by 4 in this case. And now the absolute value is there just so that in case b was negative, then just keep in mind period's always positive. Amplitude's always positive also. Okay, so now shifts can be positive or negative, but amplitude and period are always positive. Okay. All right, let's do another one. I had so much fun with that one. Okay, I did. Y equals 1/2 times the cosine of x over 3. Okay? All right, so cosine graph, it has the same basic shape as sine, but instead of starting at 0, 0, it starts at the top. Okay, so I always, whenever I do this, I try, if I'm working on a grid, I try and set it up so either I have 1, 2, 3, 4 squares for a full cycle because I break it up into 4 chunks, or instead, depending on the size of my squares, I might do 2, 4, 6, 8. So again, but some multiple of 4. I might even stretch it out longer, especially if my squares are a little bitty, and say there's a chunk, there's a chunk, there's a chunk, there's a chunk. Just to understand that those 4 chunks need to be the same width. So if you're going to do 3 squares per chunk, do 3, 3, 3, 3. Or if you're going to do 1 square, do 1, 1, 1, 1. Okay. Now this particular grid, I'm very, very happy to do 2 little squares per chunk. So here I am, graphing along. Start my cycle at the top because this is cosine. Okay, cosine has a basic shape that looks vaguely like that. That's really crazy, really, scary looking. Okay, so that means I end a cycle wherever I start it. Now, if I'm starting it at the top, then the middle is going to be in the bottom, and between the top and the bottom are zeros. Curve, 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 curve. I'm going to do it again one more time on the right. You see me do this with sine. Okay, at the top, at the bottom, halfway, halfway, lots of curves. Okay? All right, let's do one more on the left just so we can kind of make the people with the balance issues happy. Okay, so that's the shape. Now the question is, how are we going to number this? Because I already did this. Okay, so let's do this in radians. Okay. Now a full cycle, if we were in degrees, would be 360. Normally. Okay, normally 360, also known as 2 pi. Okay, now period is about x's. Well, this is dealing with x. So in the equation, I'm dividing by 3. Inside, dividing x by 3. Inside, inverse, the inverse of division is multiplication. So that means in this case, I'm really going to be doing 3 times 360, also known as 3 times 2 pi, 6 pi. Now, if this is going too fast, you are in charge of the pause button. You are in charge of the rewind button. So do what you need to do so you get what I'm saying. I just can't make, 50-minute videos. Okay, so the period is 6 pi, or if we were doing this in, excuse me, in degrees, it would be like 1080 or something like that. Okay, so right here, it went a full cycle, so I'm going to call that 6 pi. This is another full cycle, so we'll call that 12 pi. Okay, back over here, negative 6 pi. Now, I don't need you to number every square. I do need you to number enough so that I know what you're numbering by. Okay, so I have plenty of numbering on this x-axis as it is. Okay, so what's the period? It's 6 pi. Okay, in radians. Again, if we were in degrees, we'd be doing 3 times 360. Well, how does that shake out with this? Okay, well, period is supposed to be 2 pi over b. Okay, or absolute value of b. I just typically remember it has to be positive. Well, what is b for this equation? Well, it's really 1/3. Now, most of you hate the sight of a fraction, and oh my gosh, if a fraction has a fraction in it, the world must be coming to the end. It must be 2012. Oh yeah, that already happened. All right, so same idea. 2/3 divided by, 2 pi divided by 1/3. Well, that's the same thing as 2 pi times 3 over 1 multiplied by the reciprocal, so 6 pi. Okay. All right, again, you could have done that with 360 if we were in degrees. Okay. All right, now the other thing that we need to do is work out the y-axis. Well, it is half as big. Normally, sine and cosine go up to 1, so this little guy is half as big because there was a vertical shrink of 1/2. If it's on the outside, do what it says. We're multiplying by 1/2, so 1/2 times 1 is, you guessed it, 1/2. So this little guy has got to be negative 1/2. Well, the amplitude is the absolute value of A. It is the absolute value of 1/2, so we're just going to call that sucker 1/2. Okay, again, we don't have any shifts going on, so we don't have to worry about those. Domain and range, well, domain for every sine function or cosine function is always all real numbers. I'm not talking about cosecant or tangent. Those are weird. They have all kinds of jacked up stuff going on. That's a whole different section. We'll deal with that when it comes. I know I'm scaring you. I'm sorry. range. Well, this particular one goes from a negative 1/2 to a positive 1/2. So I'm going to say from, you guessed it, negative 1/2 to but Mr. Sanford, this is in radians. It doesn't matter. The range is about y values, and that's not radians or any of it. Okay? All right, I want to do one more, and it's not going to be pretty. Okay? All right, so let's just go one more. All right, so let me write it down. Okay, so this particular one has some addition inside it. So as you know, addition really relates to translations or shifts or slides. Now, a quick little note here that this shift, this slide, it's on the inside, and so it's going to deal with x. It's going to be in the horizontal direction, and it's going to be a phase shift. Now, from when we did this back in the day, when we did shifts, you know, and slides and all that stuff, my recommendation then and my recommendation now will be to do everything about scale changes first, so multiplication and all that kind of stuff, do all that stuff first, and then we'll do any slides as a secondary graph, as a, you know, we'll move the image kind of thing. So remember, any shifts will come after scale changes, so we'll deal with all the multiplication and division first, and then we will do the shifts, okay? All right, so here we go. First of all, this is a sine function, okay? And I already have a pretty good feel for how that's going to look. And again, it starts at 0, ends at 0, halfway through it's at 0, and you're just going to hear me say this like 100 times, and then follow those points. Now there's a catch. There's a negative sign out front. If I multiply on the outside by a negative, then remember the idea there is all my y values have changed signs. So it actually flips upside down because of the negative. It is to my advantage to deal with that right out of the chute when I'm first graphing. Okay? All right, so here we go. Sine starts at 0. It ends at 0. Now again, I'm going to scale so that's one full cycle in 8 squares. Again, you don't have to follow that exactly. You know, you could do 4 squares if you want. I know on regular old paper this is going to get a little ugly. Okay? All right, halfway through, we're at 0. Normally, I would put a point right there and right there. Again, because it's upside down, I'm going to switch those. Okay, so I'm going to do on the bottom and on the top, and I'm just going to sketch that bad boy in. Okay, now what I'm graphing right now is y equals negative 3 times the sine of 2x. This is what this blue graph is going to be. Okay, I'm going to do another cycle. Okay, you know me, I like to have at least 2 cycles. Feels weird graphing upside down, but that's just how it is. Okay, so again on this side, and again normally the one on the left is on the top. Well, this one it's on the bottom because it's upside down. Okay, let's add a little scale to this. So for instance, I know that my period, well, the period is 2 pi over b. So period 2 pi over 2 is pi. Okay, so the period is pi. So that's right here, pi. This would be negative pi. If you were going to stick one on the right end, that would be 2 pi. Okay, 2 pi lives. Well, shout out. All right. So far so good. Now the other issue is that this seems kind of weird having 2 squares to be 3, but it is what it is. I just graphed it like I always graph a sine function. And so there was a vertical stretch of 3. So this is now 3. This is now negative 3. Now don't go making the top a negative. That just doesn't happen. The positive numbers have to be on top. Now amplitude related to that, amplitude is the absolute value of A. So the absolute value of negative 3. Remember, amplitude is always positive. Okay. All right, so I haven't dealt with, well, we can do domain and range. Domain, as you know, is all real numbers. Range, there is no vertical shift. If there was a vertical shift, I would wait to do the range. Okay, so horizontal shift would just move my x values to other x values, which all real numbers are still all real numbers, even if I slide them back and forth. Okay, so the range is going to be from negative 3 to 3. Now, again, if you'd rather do inequalities, you're welcome to do that. Okay, all right, now phase shift. Now this is where things get less than pretty. Okay? All right, so the phase shift here is going to be, now how did I know I was in radians way back? Sorry, I didn't mean to interrupt myself. But like I scaled all of this in terms of pi and 2 pi. How did I know I was in radians? Well, notice this little guy is clearly not in degrees, so I guess that's how I knew I was in radians. If there's nothing specifying or giving an implication, then you could graph in either way, in radians or degrees. But since this says pi over 3 specifically, then you have to go radians. All right. Now, normally as I look at this, I would think pi over 3 was added inside inverse. I would say negative pi over 3. Now, the only catch is, and I know we played around with this a long time ago, if I actually find the inverse of what's inside, the thing added to x is also divided by 2. Okay, so I'm giving you kind of the shortcut right here, and if it were me, I'd just memorize this sucker. The horizontal shift is not just the opposite of this number. Okay, so notice that I'm following a format here, right? So it's not just the opposite of this number here, it's the opposite of that number divided by b, divided by the number in front of x. So negative pi over 3 divided by 2 is the same thing as negative pi over 3 times 1/2, also known as negative pi over 6. So the phase shift is negative pi over 6. The vertical shift, there's nothing added or subtracted on the outside, so we'll just call that 0, or again, if you want to call it not applicable, or what are you trying to pull, Mr. Sanford, or something like that. All right, so we're going to shift left pi over 6. Now here's the problem. What the heck does pi over 6 look like? Well, pi over 6 is not going to be pretty with the grid that we have going here. So just understand that, well, pi over 3, well, that'd be 1/3. One way to do it is try and picture all of this from here to here divided up into 6 chunks. So it would be something like, well, into thirds. Sorry about that, must be time to go. I know somebody's looking at the clock going, yep, it's time to go. Well, pi over 2 is here. 1/3 of that would be something like this. So if I keep dividing that up and those into thirds, that's roughly pi over 6. Now, understand that I am not going to get out a tape measure. I am not going to get out a ruler to measure this when I'm grading this. So, and I'll try and pick numbers that are a little more friendly than this. Like if I would have had, pi over 4 there or pi over 2 there, this would have been a little nicer. But this is good that we're dealing with one that's less than pretty. Okay? So you could even, 1/6 is 0.166, so you could say something like, if you tried to scale this, you could play around with it a little better, but I think this is good. Just kind of eyeball 1/6 of the way from pi or whatever. So it looks like maybe a little less than a square and a half. So what I'm going to do is, now again, this is negative. Okay, so I'm going to shift every one of these points to the left about a square and a half, not quite. Okay, so here's a square and a half to the left. Here's a square and a half to the left. Here's a square and a half to the left, etc. Okay, so I'm going just a shade under a square and a half to the left. And I'm just eyeballing it. I am not getting out a ruler. I'm just winging it here. Okay. Okay, so what I'm doing is I'm like looking at that point. I'm looking at that point. I'm looking at that point. Okay, so that's what I did with every one of these. Okay. Okay, I know you can't see exactly what I'm doing. Now, like before when we did the shifting of graphs, if you you need to somehow make a distinction between your final image and whatever your pre-images were. So like, I'm going to highlight. Okay, now if you want more practice with this, you can go back to section 1.4, but it wouldn't be with trig functions, it would be with something similar. Okay, and I'm just going to leave it at that. I'm already going long, and that was a big time example right there. So, all right, well, practice, practice, practice. We will be doing lots of it. Thanks for staying with us. Sanford out.